Alright, so in this video I'm going to look at solving two-step equations where instead of x being multiplied by something, it's being divided by something. Okay, so it's pretty much the same process as what we've done in the past. We are looking to, first of all, get rid of our constant. So that is the number that is not attached to the variable. So the constant is the thing that is added or subtracted to the equation or to the variable. So if I'm adding 5, the opposite of that would be to subtract 5. Now remember, our equals sign here says that everything on both sides of the equals sign needs to be done the same. So whatever I do on the left side, I have to do on the right side because I have to keep everything balanced. Both sides want to be treated equally. So if I subtract 5 on the left, I also have to subtract 5 on the right. When I subtract 5 on the left, if I add 5 and subtract 5, those guys just cancel each other, and now I'm left with x over 3 is equal to, and 14 minus 5 gives me 9. So to finish that, I now need to get rid of that 3 that's attached to the x. That one says x is being divided by 3. The opposite of dividing by 3 would be to multiply by 3. So I can just put the 3 up here next to it. If you want, you could wrap it in brackets to show that it's going to be multiplying. And I'll wrap it in brackets on the other side as well. If I multiply by 3 and divide by 3, 3 divided by 3 is 1. And then 1 times x is just x. So we get our 1x left over. And that's because our 3's cancel one another out, because 3 divided by 3 is 1. On the other side, 9 times 3, that gives 27. Okay, so when we're solving, the first thing we do is we get rid of the constant. After that, x was being divided by something, so we multiply by that same value on both sides. Okay, now we are going to verify as well, so let's make sure we know how to verify in our at the end of our equations as well. So this one says x divided by 4 subtract 5 is equal to 6. So the opposite of subtracting 5, I got to get rid of this constant first. The opposite of subtracting 5 would be to add 5. And I'm going to treat both sides equally, so I'm going to make sure to add 5 on both sides of the equal sign. That gives me now x over 4, or x divided by 4, is equal to, and 6 plus 5 is 11. Now the 5's here, one was negative, one was positive. They cancel one another out. They create 0 when they add together. So we're just left with that x over 4. Now to get rid of that dividing by 4, I need to multiply by 4 on both sides. That's my opposite operation. Okay? When I multiply by 4 and then divide by 4, I get 1. And so that means I'm just left with 1x in the end. And 11 times 4 is 44. So we said the value of x, that missing number in that original equation, should be 44. So I'm going to start off checking, verifying, by writing the original equation that I had in white before I started doing anything there. So I had x over 4 minus 5 on the left-hand side of the equal sign, and on the right-hand side I had 6. And we said that x should be 44, so what we're going to do is we're going to change x. And instead of writing x, we're going to write it as 44. So I'm going to substitute it back in to my expression. So instead of it being x over 4, it's 44 over 4. Order of operations says I have to divide before I subtract. So I need to do that division first. 44 divided by 4 turns into 11. And then I've got 11 minus 5, which is 6. And that's great because I've showed that both sides of my equation are the same thing. Okay, do a couple more really quickly. X divided by negative 5 plus 6 is equal to 4. So I'm going to subtract 6 on both sides instead of adding 6. These 6's here are going to cancel. And now I have x over negative 5 is equal to negative 2 on the other side. 4, take 6 away, we get negative 2. Now I'm going to multiply both sides by negative 5. So I want to include that negative in there because I'm going to get rid of everything all at once. Negative 5 divided by negative 5 is 1, which means these guys are canceling. And 1 times x is just x. On the other side, negative times negative is positive, and 2 times 5 gives us 10. We said x should be, in this case, 10. So if I have x over negative 5 as my original expression, plus 6 on the left, and on the right we had 4. Now we said x should be positive 10, so we'll put in positive 10 divided by negative 5 plus 6, and I have to do, according to order of operations, I have to do this first because I divide before I add. Positive 10 divided by negative 5 is negative 2. Negative 2 plus 6 gives us positive 4, and we have the same thing on both sides of the equal sign. Okay? What if I had something like this? Negative x over 2 plus 7 is equal to negative 9. So you might remember we talked about this in our Solving One-Step Equations Part 3 video. If I have negative x over 2, that's the same thing as x over negative 2. Okay, the negative is allowed to move from the top to the bottom or from the bottom to the top. It's allowed to travel if we want. Generally, we leave it at the front of the fraction in the top with the numerator, so it's the first thing we see. However, it is not incorrect to move it to the bottom. So I'm just going to move this negative from, instead of being in front of the x, I'm going to move it in front of the 2. And the reason I'm going to do that is when I multiply later on, both sides, I can get rid of that negative all at one time, and that makes life a little bit simpler. So I'm going to start by subtracting 7 on both sides so that my constants will cancel on the left. And now I've got x over negative 2 is equal to negative 9 minus 7 more, or negative 9 take away 7 more, gets us to negative 16. Okay? And now I'm going to multiply both sides by negative 2. Now, I might forget to multiply both sides by negative 2 if that negative sign had been sitting up in the top next to x. And that's why I moved the negative sign down so that it was part of that divisor. Okay? I moved it down so it was part of the divisor or the denominator. So that way when I do my opposite of dividing by negative 2, it's multiplying by negative 2, and I take care of the negative right away, and it's going to disappear. Negative 2 divided by negative 2 gives me 1, and then I've got 1 times x, which is just x. On the other side, negative times negative is positive, and 16 times 2 gives me 32. Okay? Now, I am going to go back to my original equation before I started messing around with everything. So I got to even put that negative back where it was. So I had that negative attached to the x, okay, up top. So I got to leave it there. And I had negative x over 2 plus 7 on the left-hand side and negative 9 on the right-hand side. So I've got negative, and then instead of x, I'm putting in positive 32. Now this looks a little bit weird again, okay, because I've got negative positive 32. Well, negative positive 32, if I've got two signs next to each other like this and I've got negative positive, I have just that one negative sign. Remember, if there's an odd number of negatives, that means that we have a negative answer. So this really is the same thing as just negative 32 over 2. Okay, negative 32 divided by positive 2 gives us negative 16. Negative 16 plus 7 is equal to negative 9. So we have the same answer on both sides. Okay, last one. I got x over negative 9 minus 4 is equal to negative 10. I'm going to add 4 on both sides to cancel that out. We get x over negative 9 is equal to, on the other side we get negative 6. Then I'm going to multiply both sides by negative 9 so that the negative 9's cancel. Left with x is equal to negative times negative is positive, and 6 times 9 is 54. We'll check that we have the correct answer. We started with negative 10 on the right, and we started with x over negative 9 minus 4 on the left. If I put in positive 54, and I divide that by negative 9, 54 divided by 9 gives me 6, and positive divided by negative is negative. So if I have negative 6 and then I take away 4 more, I'm at negative 10 in total. Okay, so that's solving two-step equations part 2, where x is being divided by something instead of adding to something. And you can see it's pretty much the exact same steps. We still get rid of that constant first. And even this part, even though, yes, I started off by dividing, and in the other ones I started by multiplying, this part still looks exactly the same in both equations. You got to have one number up top and one number in the bottom. So one number is multiplying, one number is dividing. And really it's the same thing. It looks exactly the same as our last solving video. So solving two-step equations part 1 really looks the same. Okay?